Jai Hind. My name is Parde and I am working as an assistant professor in IT department in Ajay Kumar Garg Engineering College, Ghaziabad. So today we will discuss the subject theory of automata and formal languages, and our today's topic is introduction to regular expression, and the subject is TFL. TFL in short, okay, it is a theory of automata and formal languages, and the subject code is KCS 402. So let's see some introduction. A regular expression can be defined as a language or a string accepted by finite automata. It is defined as a language or a string accepted by finite automata. We know that a finite automata consists of 5 tuples. What are those 5 tuples? Q, sigma, delta, Q node and F. Q is the set of state, sigma is the input alphabet, delta is transition function, Q node is initial state, F is set of final state. And among them, a regular expression is a string on sigma. It will consist only input with input alphabet. In short, regular expression is written as RA. We can write regular expression in short RA. Okay. A regular expression can be described as a sequence of pattern that define a string. Regular expression are used to match character combination in the string, and searching algorithm use this pattern to find operations on a string. So this is some basic of regular expression. It is basically a language or string accepted by a finite automata. There are 5 tuples Q, sigma, delta, Q node and F. Okay, and it is a sequence of pattern that defines some strings. Okay, and it is used by string searching algorithm to find the operations on a string. So there are some primitive regular expression. So on the left hand side there are regular expression, and on the right hand side there are regular languages. Okay, so phi is the regular expression and the corresponding regular language is null set, empty set. Okay, this epsilon is regular expression. Okay, and this is the regular language which contain only one element, which is epsilon. Suppose there is one regular expression A, so it will contain only one element, so this is the corresponding regular language. Similarly for B also. Okay, so let's see what is this epsilon. Okay, so epsilon is a string of length 0. Okay, epsilon is a string of length 0, whose length is string 0. Okay, it is a string of length 0. And what is phi? Phi is empty language which do not contain any element. Phi is the empty language. Okay, this is very important. These two things are very important. Epsilon is string of length 0 and phi is empty language. Okay, so we denote this empty language by this empty set phi. Now next see the operations on regular expression. So first operation is union operation, second is concatenation operation, third operation is clean closure, fourth operation is positive closure. This plus sign and this plus sign is different. Okay, let's see some example. Suppose there is language L1, okay, which contain element A, and there is language L2 which contain the strings A, B, B and B. Okay, if we perform the union operation, it means the language L1 union L2, or you can also write as L1 plus L2, both are same. Okay, so the language will be A plus A B, since A is common in both the languages, so B, let's erase this one. So B plus B and B. Okay, this is the union of this language L1 and L2. Next is the concatenation. If we apply the concatenation L1 concatenation L2, it means every string of language A is concatenated with every string of language L2. So this will be equivalent to A dot A plus B plus B B. Okay, so the resulting language will be A dot A is A dot B is AB, and A dot BB is AB B. Okay, so this is, okay, I need to write now. We can write is AA AB A BB. Okay, I have concatenated language L1 string with language L2 string. Okay, next see the clean closure. Okay, so if I applied clean closure of language L1, okay, this will be, what is language L1? A, language is A. If I apply star, then the language will be epsilon A A A A A A up to infinity. So what is the meaning of clean closure? It means it is something like its power. Okay, so A raised to power 0, A raised to power 0 means epsilon. Okay, this is A raised to power 0, A raised to power 1, A raised to power 2 and so on. Okay, next is the positive closure. So suppose L1 plus language is A, I apply the positive closure. So this will be equivalent to A raised to power 1, A raised to power 2, A raised to power 3 and so on. Okay, so this is some basic operations on regular expression. So this we have covered. Okay, so phi is empty set, regular expression is epsilon. So this regular language contain one element epsilon. A star means this epsilon is A raised to power 0, A means A raised to power 1, A means A raised to power 2, 3 times A means A raised to power 3 and so on, up to what? Infinite. Up to what? Infinite time. So this A star is an infinite. Similarly A plus, so A plus means 0 is not included. So A raised to power 1, A raised to power 2, A raised to power 3 up to infinite. Up to infinite. Next A plus B star, it means suppose sigma is equal to, in this case sigma equal to A and B. This is input alphabet, or this input alphabet A plus B star means set of all strings over AB. Set of all strings, set of all strings over sigma equal to A comma B. Okay, it means a universal language over sigma equal to A plus B. Next, epsilon star. So this is very important, that epsilon 0, okay, epsilon 1, epsilon 2, epsilon 3 up to infinity. Okay, this will be equivalent to epsilon power 0 equal to epsilon, epsilon power 1 equal to epsilon, epsilon power 2 equal to epsilon, 3 equal to epsilon up to so on. So this is equivalent to epsilon only, okay, because set does not contain duplicate value. So this epsilon star equal to epsilon 1. Similarly for epsilon plus, okay, this is equal to epsilon. So here epsilon power 0 is not included. In case of epsilon plus, this epsilon power 0 is not included. Epsilon 1, 2, 3 equivalent to epsilon, okay, and this is equal to epsilon itself only. Third one is phi star. So this is equivalent to phi power 0, okay, phi power 1, phi power 2 up to infinite. So this is phi power 1, these are empty set. Phi power is 0 equal to epsilon, so it will contain only one element, epsilon. Phi plus means phi power 1, phi power 2, phi power 3 up to so on. So this is equivalent to phi only, there is no set, okay. Next is some important thing, that for a given language, there can be more than one regular expression. It is very important. For a given language, there can be more than one regular expression. Means the answer is not unique. There may be one regular expression for a given language. So answer is not unique. There can be multiple regular expression corresponding to a given language. Okay. Next is some example. So there is question that write the R stands for regular expression for the set of all string whose length is exactly 2 over sigma equal to A comma B. Okay. So here input alphabet is A and B, okay, input alphabet is A and B, and language is all string whose length is exactly 2, whose length is exactly 2. So the language contain what element? A, B, B, A, B, B. These are the all combinations, okay. So this is the language. So corresponding to this language, we need to write regular expression. So there are maximum two input letters, okay. So first letter contain either A or B. It means either A or B. It means A or B, okay. And second also contain, it can be either A and B. So this is the regular expression, okay. This is the regular expression for the given language, okay. So it will contain all the set of string whose length is exactly 2. Next, see, write the regular expressions for set of all string whose length is at least 2, whose length is at least 2. So the language is length is at least 2, length is at least 2. So it can be AA, AB, BA, BB, AAA, ABB, ABA, and so on. Means length is at least 2. It means that epsilon is included? No. A is included? No. B is included? No. Because these are string of length 1 and the question is at least 2. Okay. So the correct answer will be, so the correct regular expression for this one is length is at least 2. So it will be A plus B and A plus B and A plus B star. So this contain length 2, this string contains length equal to 2 and these contains 0 or more. Okay, 0 or more length. Okay, so 2 plus 0 length 2, 2 plus 1 length 3, 2 plus 2 length 4, so at least 2. Okay, so there can be one more regular expression corresponding to this. So I can also write as A plus B star, A plus B and A plus B. This is also the possible regular expression. Similarly, I also can write as A plus B, A plus B star and A plus B. Okay, so this is regular expression 1, this is regular expression 2, this is regular expression 3 for the same language. Okay, there can be more than one regular expression for the one language. Okay. Next, see, write the regular expression for set of all string whose length is at most 2, whose length is at most 2. So the length is at most 2. So length can be 0 means epsilon, length can be 1 A and B, length can be 2 AB, AA, AB, BA, BB. Okay. So more than 2 it is not possible. Maximum length will be 2. Length will be maximum length will be 2. So the regular expression will be, so there are two places. Okay, there are two places. At one place there can be A, there can be B, or there can be nothing. So I can write epsilon. And at the second place also there can be A, there can be, and there can be nothing. Okay, so this is the required regular expression. Okay, for length whose length is at most 2. Let's see the set of all string of even length. Length will be even. Okay, so the language will be just like epsilon, because 0 length is also comes under the category of A. No, this is not even length. B, no. AA, yes. AB, yes. BA, yes. BB, yes. AA, no. AB, yes. Okay, and so on. There can be infinite set of strings. Okay, so even length string, so regular expression can be something like that, A plus B raised to power n. Okay, so we can write as A plus B 2 raised to power n. Okay, even length. Now I can write a plus b and a plus b. Okay, and this n can be equivalent to star. So this is the final required regular expression. This is the final required regular expression. Okay, their length of string is even. Okay. Next is set of all string whose length is divisible by 3. Whose length is divisible by 3. It means length language will be epsilon. Okay, 0 is divisible by 3. A 3 times A B A 3 times. Okay, A B B B B B 6, length 6, and so on. There are infinite set of string. Okay, length of string is divisible by 3. So the regular expression will be that a plus b raised to power 3n, something like that. It is similar to the previous problem. So I can write it as a plus b, a plus b, a plus b, and whole raised to power n. Okay, and this n will be replaced through this star. So I can write it as a star here. Okay, this is the required regular expression. This is the answer. Okay, this is the clean closure. Next, for set of all string where length of string mod 3 equal to 2. Okay, length of string mod 3 equal to 2. So here what it means, suppose length is 5. 5 mod 3 equal to 2. Length is 7. 7 mod 3 equal to 1. So 7 length string will not be considered. Suppose 8. 8 mod 3 equal to 2. So this type of string will comes under the category of the required strings. Okay, so we can write as that the required regular expression will be a plus b 3n plus 2. 3n plus 2. Okay, so this will be divisible by 3 and this is the remainder. So we can write a plus b, a plus b, a plus b whole raised to power n, and a plus b, a plus b. Okay, there can be more than one regular expression. This is one of them. So the required will be a plus b, a plus b, a plus b whole star, and a plus b, a plus b. This is the final answer. Okay, this string is divisible by 3 and this is the remainder. Okay, so it contains 3 and 2 5. It contains 6 if this power is 2, 6 and 2 8, this power is 3, 9 and 2 is 11. Always remainder will be 2. Okay, next is set of all string where number of a's are exactly 2. So the required regular expression are number of a's are exactly 2. So the a must be 2. A must be 2. Initially there can be any number of b, in between there can be any number of b, and at the end there can be any number of b. So it is the exactly 2 a's. Okay, next see for set of all string where number of a's are at least 2. Number of A's are at least 2. So the regular expression will be number of A's are at least 2. Okay, so there can be at least 2A. Initially there can be any number of A and B. Okay, in between there can be any number of A and B, and at the end there can be any number of A and B. So this is the required expression for at least 2A. Number of A's are at least 2. Next, see, the number of A's are at most 2. Number of A's are at most 2. So the required regular expression will be, there can be 0A, there can be 1A, and there can be 2A. So the required regular expression will be there can be at most 2 A's. Okay, at most 2 A's. So before that there can be any number of A and B, there can be any number of B, but only 1 A. In between there can be any number of B, okay, and A plus B epsilon, and there can be any number of B's. Okay, so at most there are 2 A's. If epsilon will be taken, then there can be epsilon and epsilon 0 A's. There can be A, there can be B, 1A, B, A, 1A, B, B, 0A, A, 2A. At most 2 A's are possible. Next, for set of all string which start with A. So the regular expression over sigma equal to A and B start with A, and there can be any number of A and B. All string containing A. So the regular expression will be A plus B star. It will contain A and A plus B star. Okay, this containing A. Set start and end with different symbol. So it contains A plus B star, and B. Start with A, end with B, and start with B, end with A. So this is the regular expression, that start and end with different symbols. Next, start and end with same symbol. So the regular expression will be start and end with same symbol. Start with A, end with B. Start with A, B, end with B. A only, A is start with A, end with B. B only, B start with A and end with B, epsilon. So this is the regular expression. Okay, thank you.